Hello, friends. Welcome to another session. So today we are going to talk about one of the topics in algebra which are very relevant, and we see over the years there are two, sometimes three questions coming out of this topic. So we are going to talk about today is on logarithm. So we have already covered simple equation, linear equation, the quadratic equation, indices, graphs, typically inequalities in algebra. So we are doing this algebra series, and logarithm is the next chapter. And I think after this, we will left with progression and function. So we'll do that. But today will be the fundamental class of logarithm. So we will talk about the concepts, the very basic understanding of logarithm, how to apply logarithm, when to apply logarithm, what are the different properties of logarithm. So these are the primary things that we are going to talk about in logarithm. The type of problem that can come in logarithm is simplification. So you may give a logarithmic expression and ask you to simplify the problem and match it with any one of the options, or they will ask for finding a value. So we will see when we solve those problem. But let's say a logarithm expression where there is a x or y, any variable involved, they ask you to find you the value based on equating with some other variable, some other constant or integer term. Now, so these are the two main type of problem that can come in logarithm, and we will deep dive in each of these when we do the practice sessions. Today's session will be on fundamentals. We may not be going in depth in terms of the problems, but we will first understand what is logarithm, how to apply it, and what are the properties. Now you may or may not have done logarithm earlier, but whatever be the case, this is a very good starting point. Even if you have not done this earlier, we will start from absolute basic, and from there we will see what are the different things that you need to know before solving a logarithm problem. Okay, let's move on. So if we see, let's say there is an expression. So if we have done indices and surds kind of a problem. So let's say I say, a to the power x is equal to y. Now this is an expression. Now if I have, so here y is represented in terms of a and x. So y in terms of a and x is given. Now if I have to make a, I can write a equal to y to the power 1 by x. Basic understanding from your indices class, that if a power is there for a equation, for a term, on the other, if you take it on the other side, it will become 1 by that power. So this is basically a in terms of x and y. So I know y how to write in terms of a and x, a in terms of how to write in terms of x and y. But what if, how can I write x in terms of a and y? Can we do this with our only indices understanding? No, you can't write with only knowledge of indices x in terms of a and y. So that's where the logarithm comes in typically. And logarithm is nothing but, think of that as an operator, like you have a plus, minus, something. Logarithm is an operator. And if you add, so log, so this is the way we can write log. So log of e to the power x, and you can take log on both the sides. So basically log is an operator, and I am using log on both the sides. So that becomes x log a equal to log y, or we can say, uh, or I will come to this property later. So if I do this, I'll just try to write the answer and I will show you how to get this. So x is basically logarithm of y base a. So basically what I'm trying to say is, if a to the power x is equal to y, you can write x as log of y base a. So how to read that? So this is called as base. And how we will read that? Log of y base a. So this is the way you should read this. So this is the way you should read this: log of y base a, right? And a is the base and y is basically the log of that. So for example, if you have let's say 5 to the power 7 is equal to x. I'm just writing. So here I can write 7 is log of x base 5. Okay. So log of x base 5, right? So what we understand is, so if I write, let's say m to the power n is equal to a. So we can write n is equal to log of a base m, right? So this is what it's all about. So log of a base m. Now, what it needs to be there? A has to be a positive number. So basically, a has to be a positive number. A cannot be a negative number. So this is the first understanding of norms. So there are two conditions. Condition number one, a has to be a positive number, and then there is a second condition. The second condition talk about m is a positive number other than 1. So these are the two conditions that any logarithm will satisfy. So the number log of whatever number is given, that number has to be a positive number, and the base has to be a positive number other than 1. So that's what you need to identify. So okay. So this is one part. So these are very important understanding. So if I cannot write log of -5 base x, that is not possible. Or I cannot write log of 5 base -2, that is not possible. Or if I can't write log of 5 base 1, that is not possible. Why log of 5 base 1 is not possible, you will understand when I talk about the properties. But as of now, understand that a or the log of that number, the number cannot be a negative number, it has to be a positive number, and the base has to be a positive number as well, but it has to be other than 1. Now there are, depending on base, there are two type of logarithm. There are two type of logarithm. The number one is common logarithm, and common logarithm is normally denoted as log, the way we have seen earlier. So log with a base of 10. So it's base of 10. So when the base is 10, that's when we call it as common logarithm, right? So if nothing is mentioned, if nothing is mentioned, consider all logarithms as common logarithm. So if nothing is mentioned in a problem, you normally do common logarithm with base of 10, right? And the other logarithm is natural logarithm. The natural logarithm basically says log of x base e. So when e is in the base, that's when it's called as a natural logarithm, right? So hope you understand the difference between natural and common logarithm. So if nothing is mentioned in the base, we can consider all logarithm as common logarithm. Nothing is mentioned in base, consider all logarithm as common logarithm with base 10. So this is first part. So if nothing is mentioned in the base, consider all the logarithm as common logarithm with base 10. So this is the first, and then there are certain logarithm which will have logarithm with the base of e. These are the two type of logarithm. Now the most important part, the properties of logarithm. So the first property of logarithm, okay, before we go there, a log of 10 is basically 1, right? You can remember this. And log of 1 is basically 0, right? Now, if you see this, you can understand why we say a simple logarithm. If I go back to this example, where log of a base m, now I said m cannot be equal to 0, m cannot be equal to 1. And this will be explained when I will tell you the properties. Okay, let's first tell the properties, then I'll go there. So log of 1 equal to 0. Then you know, if there is a log of a base x, you can write this as log a by log x. So you can write this, and both can be base. If nothing is said, you can consider both as base 10, right? Then if there is log of a to the power m, you can say this is equal to m log a, m log a. So then we can say log of a into b. You can write this as log a plus log b. This you can write. Now if you have log of a by b, you can write it as log a minus log b. These are very, very important formulas of log. So you need to understand these formulas, and you need to apply this in certain cases in these logs. Okay. On the 7th, let's say there is log of x to the power y and a to the power m. So base is x to the power y and the number is a to the power m. In that case, you can write m comes front and y comes front, m by y log of a base x. So you can understand from here. So m comes front if m is a power of the number that has a log, and if the base also has a power, that will also come outside as the denominator. So okay, this is one case. Now there is another. So if I have log of a base x, I can write 1 by log of x base a. So this is one way of changing or changing the number to the base and base to the number. So this is an important formula. Okay. Now there are few more formulas. I'll just reduce it. Okay. Now there are few more formulas. Remember, one is, I'll go to the next one. So then there is log of a, and base is also a. So in that case, this is 1. So if you remember, in the previous one, we said log of a base x can be written as log of a by b. So here we can say log of a base a is equal to 1, right? We can also say, so if you see this formula typically, where we said log of a base x is same as log of a by log of x. So here we did the same thing, log of a base a. So this is log a by log a, which is equal to 1. You can do that. If you have log of a base x, you can write this as log of a base b, log of x base b. So basically what we are doing here is we are introducing a new base, which is b, for in both, and that's how we can write it. Again, this can be derived from this, where we say okay, which is the one we can use. Yeah, the same one, log of a by log of x. So if I have to show you this, we can say the first one can be written as log a by log b whole divided by log x by log b. Log b will get cancelled. It will become log a by log x, which is the same as the given one in this case. So this is one formula. The other formula typically have, if we have a to the power log of a to the power log of a, that is also equal to 1. A to the power log of a, that is equivalent to 1. So this is the main formula, and there is one more. Then there is one more formula. If we have a to the power log of n base a, in that case, this is equivalent to n, right? And the last one I want you to remember is, if there is a to the power log of b, same as written as b to the power log of a. So these are the around 12 to 13 formulas which you absolutely need to remember. Now, if I go back and see here, why I was saying the aim cannot be equal to 1, because then you can write this as log a by log m. Now, if your aim is 1, your log a by log 1 or log a, like we know, it will become 0. So then n cannot be equal to 1, because then it becomes indefinite. So that's why the second formula, am is a positive number other than 1. Right? So these are the few fundamentals, or these are the 12, 13 formulas of log which you need to remember. And with this, we will be able to solve a lot of problems in the coming session. But if you understood this and try some of the basic problems with this, and we will start the next session, which is focused on primarily using any of these formulas. So most of the logarithmic problem will use this 13 formulas in some way or the other. So understand this, try some of the basic problems at home, start trying and see where you are there. If you are unable to solve, it's perfectly fine. We will do a complete deep dive. We will solve around 10, 12 problems. And across 2 sessions, we'll do around 20 problems. So you will be able to completely understand the logarithm and all the type of problem that can come. We'll not typically dive into the problem, but we wanted to cover some of the basic fundamental nuances of log. And with that, we'll see you in the next session, where we will deep dive into the problem. And if you have any doubt here, you please let us know. And plus, please keep this handy when we are solving the problems in the next session, and we'll be able to relate it much better. Okay, so happy learning. See you next time. Bye.